National Electrical Code, specifically sections 110.9 and 110.10, addresses the requirements for interrupting rating and fault current protection of electrical equipment. It's crucial to understand the difference between ampere interrupting capacity, or NEC, and short circuit current rating, or SCCR, and how these ratings apply to components like breakers and panels within an electrical system. The available fault current at a specific location within an electrical system is the maximum current that could flow under short circuit conditions. This value is critical for selecting appropriately rated equipment. The ampere interrupting capacity, or NEC, rating of a circuit breaker indicates the maximum fault current that the breaker can safely interrupt without failing. If a fault current exceeds the breaker's NEC rating, the breaker may not be able to clear the fault safely, potentially leading to equipment damage, fire, or even explosion. The short circuit current rating, or SCCR, of electrical equipment, such as a panel board or a motor controller, indicates the maximum short circuit current that the equipment can withstand without sustaining damage. This rating considers the overall withstand capability of the equipment's components and construction. NEC Section 110.9 mandates that equipment intended to interrupt current at fault levels must have an interrupting rating sufficient for the available fault current at its supply terminals. This means the NEC rating of a breaker must be equal to or greater than the calculated available fault current at the point where the breaker is installed. NEC Section 110.10 further emphasizes the need for equipment to withstand the effects of fault currents. This section requires that equipment be selected and installed to withstand the available fault current without creating a safety hazard. This includes considering the thermal and mechanical stresses that fault currents can impose on equipment. In practical applications, the available fault current is calculated by performing a fault current study. This study considers the impedance of the power source, transformers, conductors, and other components in the electrical system to determine the maximum fault current that could flow at various points. When selecting circuit breakers and other equipment, it's essential to compare the available fault current at the installation point with the equipment's NEC and SCCR ratings. The equipment must be rated to withstand the available fault current. Now, focusing on a scenario where a lighting control panel has breakers with a 10 NEC rating and the entire dimming module has a 100 SCCR rating, while the available fault current at the panel is 23 kA, the NEC requires the use of the lower of the two ratings, which in this case is 10 NEC. Because the available fault current is 23 kA, the 10 NEC breakers in this scenario are not sufficient. The breakers would need to have an NEC rating equal to or greater than 23 kA to comply with NEC 110.9 and 110.10. Firstly, the breaker must be able to safely interrupt the available fault current of 23 kA. Since the breakers are only rated for 10 NEC, they are inadequate. Secondly, if a fault current of 23 kA were to occur, the breakers could fail to interrupt the current, potentially leading to damage to the lighting control panel and other equipment. The 100 SCCR rating of the dimming module indicates that the module itself can withstand a fault current of up to 100 kA without failing. However, this rating does not override the requirement for the breakers to have sufficient interrupting capacity. The breakers are the primary means of overcurrent protection, and their NEC rating must be adequate for the available fault current. To address this situation, there are a few possible solutions. 1. Replace the existing 10 NEC breakers with breakers that have a higher NEC rating, such as 25 kA or 30 kA. This would ensure that the breakers can safely interrupt the available fault current. 2. Install current limiting fuses upstream of the lighting control panel. Current limiting fuses can reduce the magnitude of the fault current, potentially bringing it down to a level that the existing 10 NEC breakers can safely interrupt. 3. Redesign the electrical system to reduce the available fault current at the lighting control panel. This could involve increasing the impedance of the circuit by using longer conductors or adding impedance devices. When evaluating these options, it's important to consider the cost, feasibility, and impact on the overall electrical system. Replacing the breakers is often the simplest and most cost-effective solution. However, if the available fault current is very high, current limiting fuses or system redesign may be necessary. It's crucial to consult with a qualified electrical engineer to determine the best course of action. The engineer can perform a fault current study and recommend appropriate solutions to ensure that the electrical system complies with the NEC and provides adequate protection against fault currents. In summary, NEC 110.9 and 110.10 require that electrical equipment be rated to withstand the maximum available fault current that could flow through it. In the case of a lighting control panel with 10K AIC breakers and a 100K SCCR dimming module, where the available fault current is 23K, the breakers must be replaced with breakers that have a higher AIC rating, or other measures must be taken to reduce the available fault current to a level that the existing breakers can safely interrupt. Ignoring these requirements can lead to serious safety hazards and equipment damage. The AIC rating of the circuit breaker is the maximum fault current that the breaker can safely interrupt. The SCCR rating of equipment is the maximum short-circuit current that the equipment can withstand without sustaining damage. It is imperative that electrical installations comply with NEC sections 110.9 and 110.10 to ensure safety and prevent equipment failure. The available fault current must be calculated accurately, and equipment must be selected with appropriate AIC and SCCR ratings. It's always best to consult with a qualified electrical engineer to ensure that the electrical system is properly designed and installed. The electrical engineer will consider all relevant factors, such as the available fault current, equipment ratings, and applicable codes and standards, to provide a safe and reliable electrical system. Consider a scenario where a panel board has a short circuit current rating of 65K and contains branch circuit breakers with an interrupting rating of 10K. The available fault current at the panel board is calculated to be 20K. In this case, the 10K interrupting rating of the branch circuit breakers is less than the available fault current of 20K. This means that the branch circuit breakers are not capable of safely interrupting the maximum fault current that could occur at the panel board. To comply with NEC sections 110.9 and 110.10, the branch circuit breakers must be replaced with breakers that have a higher interrupting rating. The new breakers must have an interrupting rating equal to or greater than the available fault current of 20K. Alternatively, current limiting fuses could be installed upstream of the panel board to reduce the magnitude of the fault current. The current limiting fuses would need to be sized appropriately to ensure that the let-through current does not exceed the interrupting rating of the existing branch circuit breakers. Another example would be in a motor control center, or MCC, which has a short circuit current rating of 42K. The MCC contains motor starters with an interrupting rating of 18K when protected by specific fuses. The available fault current at the MCC is determined to be 35K. In this scenario, the motor starters, when protected by the specified fuses, have an interrupting rating of 18K. This rating is less than the available fault current of 35K at the MCC. To meet the requirements of NEC sections 110.9 and 110.10, one of the following actions must be taken. Firstly, the motor starters could be replaced with starters that have a higher interrupting rating. The new starters must have an interrupting rating equal to or greater than the available fault current of 35K, either on their own or in combination with properly selected fuses. Secondly, current limiting fuses could be installed upstream of the MCC to reduce the magnitude of the fault current. The current limiting fuses would need to be sized appropriately to ensure that the let-through current does not exceed the interrupting rating of the existing motor starters. Thirdly, the electrical system could be redesigned to reduce the available fault current at the MCC. This could involve increasing the impedance of the circuit or adding impedance devices. To summarize, NEC 110.9 is about interrupting rating. Equipment intended to interrupt current at fault levels shall have an interrupting rating sufficient for the nominal circuit voltage and the current that is available at the line terminals of the equipment. Equipment intended to interrupt current at other than fault levels shall have an interrupting rating sufficient for the nominal circuit voltage and the current that must be interrupted. NEC 110.10 is about circuit impedance, short circuit current ratings, and other characteristics. The overcurrent protective devices, the total impedance, the component short circuit current ratings, and other characteristics of the circuit to be protected shall be selected and coordinated to permit the circuit protective devices used to clear a fault to do so without extensive damage to the electrical equipment of the circuit. This fault shall be assumed to be either between two or more of the circuit conductors, or between any circuit conductor and the equipment grounding conductor or equipment grounding bus of the supply system, and shall be assumed to be either an arcing fault or a bolted fault. The electrical equipment shall be installed in a neat and workmanlike manner. The NEC provides detailed guidelines for ensuring electrical safety in buildings and other structures. Adherence to these guidelines is essential to protect people and property from electrical hazards. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It is important for electrical professionals to stay up to date on the latest changes to the NEC to ensure that their work complies with current codes and standards. In addition to the NEC, other codes and standards may also apply to electrical installations depending on the location and type of facility. These codes and standards may include state and local electrical codes, as well as industry standards such as those developed by the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. Electrical safety is a shared responsibility. Everyone who works with or around electricity should be aware of the potential hazards and take appropriate precautions to prevent accidents. This includes following safe work practices, using appropriate personal protective equipment, and regularly inspecting electrical equipment for signs of damage or wear. Only qualified and trained personnel should perform electrical work. Unqualified individuals should never attempt to repair or modify electrical equipment. If you are unsure about any aspect of electrical safety, consult with a qualified electrical professional. The goal is to make sure that the lowest rated link in the chain, or in this case the breakers, are properly sized for the application. A building that has 23 kV available fault current available at a piece of equipment that is only rated for 10 kV would not pass inspection and is unsafe. The breakers must be rated high enough to handle the available fault current, no matter what the other components are rated for. The lowest rated device must be able to safely interrupt the fault. If a fault occurs that is higher than the AIC rating of the breaker will explode and fail to clear the fault. This is dangerous and could cause major damage.